I can assure you that when you see this piece, you're really going to know what it is, kind of in the same way that you know 3 times 5, right? Does anybody have any guesses on what they see at this point? It's a cow. Okay, some of us are giving me very blank stares at this point. Where do you see the cow?
I see the nose at the bottom.
Okay. Uh-huh. That's absolutely right. So I heard a couple of you, as you were talking about the cow. Aha! Look at that! How do you feel when you see that cow? You can't unsee it. You know what it is 100%, right? Full confidence. Yes. And it's kind of like getting a correct answer in math. You feel very confident and you know it, and you're just, this is a cow. There's no way to unsee it. Anybody else kind of see it at this point, or are we still a little bit? In case you're still not seeing it, I do have some outlines that might point you the way. So you see that there's some ears here, and there's some eyes, and the skull's kind of outlined. The trick, though, is to look at the white space and not really at the black space. And then pay attention to that feeling that you get once you do realize that the image is indeed a cow. It's always there, whether you like it or not. And again, pay attention to that, because that's the kind of feeling that we want to capture for students when they are learning math, I think, and when they're learning most topics in education. Students have a tendency to maybe tune out now and then during a lecture or while they're reading after an exercise, but what we really want is for the learning to be very intrinsic. And one thing that's great about showing this puzzle to students is that it's really a great puzzle, because students feel delighted once they discover that this image is a cow. Often it takes a little more than 15 to 20 minutes for a few to get there. I will admit openly, though, it took me 3 nights. I did not see it right away at all. But that's kind of what this talk is about today, which is creating that emotional relationship for students in mathematics and how to teach that. So before we go further, I just want to give you a little bit of my background. I'm a teacher, just like most of you, or most of you who are becoming. I'm just here to share a few ideas in how I approach mathematics and how I like to teach math. I'm also going to share some mistakes I've made in this journey, how I learned from them, and in the process maybe became a better educator. I became a teacher because I consider myself a lifelong learner. In college, I actually double majored in art and math. I admit that that's the result of not knowing at all what I wanted to do with my life. A lot of times when I was earning my degree, grown-ups would look at me and say, wow, you're really thinking on both sides of the brain, aren't you? Not the case. In fact, I felt like I was the same person when I was taking an art class and when I was taking a math class. I felt no difference at all in right brain thinking or left brain thinking. I think that our sensation of curiosity and happiness in life really stems from 2 very abstract and core subjects. I believe that both art and math can lead to an inner joy and an inner peace when put under the correct pedagogical approaches. The first question is why we would study one topic over the other. Why would we study art? Why would we study math? They're both so abstract, and I believe that there's a lot of misconceptions about both subjects as well. I'd like to just share a few of them with you. So the first question that I want us to consider is what it is about art that moves us so much, emotionally speaking. What is it about the cultural value of art? I think that a lot of people might find the act of doing art very relaxing. I know that there's a lot of math people in the room, but does anybody do art just for fun? Yeah? And take that as many different forms as well. My journey in art actually started in kindergarten. I had a pottery teacher who had a quotation on her desk by Eric Gill. The artist is not a different kind of person, but every person is a different kind of artist. In other words, as children, I think that we're born artists, and we're really born to be creative and to have a little bit of inner soul searching that comes with the act of doing art. Somewhere along the line, though, I think as we grow more mature, we get a little bit jaded in that. The skill, though, that has to do with making great art has to do with that inner need to be creative and to share your ideas. And that's really something that I think needs to be learned and honed as we develop in art skills. I think that artists work very hard to take the reaches of their emotions and then take their emotions and transition it into some kind of form of art. What a great artist does, though, is they practice and practice and practice so that they can use their skills to produce a very moving art piece that speaks a very universal truth to other people. I think that one thing that we're only just discovering at this point, though, is that art has a very calming effect in very stressful situations as well. Recently, I read that music is actually very strongly associated with the brain's reward system. So when there's a moment of tension in a musical piece that's followed by a release, the brain actually responds by releasing dopamine, dopamine which gives us happiness. So in other words, we actually feel an emotional response when we listen to a musical piece, and that's a large part of what makes us human and what brings us inner joy. So it's happening on both a scientific as well as human level. I also believe that art is a large part of what makes us be driven to do that inner creativity. There's cultural ties to certain museum pieces, and in another scientific study, one group of scientists took brain scans of participants while they were being flashed pieces of art. When a beautiful painting like Starry Night was shown to participants, there was actually a similar increase in blood flow as looking at somebody that you love. So in other words, looking at beautiful paintings makes you feel better. Another misconception that I think comes with being an art major is a lot of people don't realize how much work that is. It takes a lot of struggle to learn how to craft in a way that evokes a response similar to what looking at Starry Night produced for us. And the truth is, I believe that math and art both require a great deal of skill and practice to get to that level to produce a piece that you really want to make. Take, for example, this Art 101 example. A student was actually asked to draw and shade an egg. And in a studio class like this, you're provided studio time, often 1 to 2 full afternoons per week, in which you're told to just draw. This art student produced an image of an egg, but you can see that there's something really off about its shading. It's very beginner level. I mean, it's still good, but compare it to this piece, that happened after a semester of practice. What makes this example so much stronger is that the shading is just more sophisticated. We're not sure how much practice it took. Nobody really does. But when you compare it to the previous one, there's actually some negative space in the piece. Notice that there's actually lack of shading and even no pencil marks in the brightest parts of the egg. That's what produces that very white effect. And as a matter of fact, where there's no shading at all, that creates a very nice contrast and the illusion of black and white. So how much time in practice will it take for a student to make this connection? If you read Brain Rules by John Medina, he actually has a chapter that says nobody really knows. And I don't have an easy answer for you. It could take one student years to get this to this level. It could take another student a simple number of months. Who knows? In fact, I think that a lot of art professors are pretty laid back in that way. Because there really isn't any pressure to teach art in one way or another. You're just taught art so that as a student you can produce art. I think that students will learn what they need to learn when they're ready, and there's no way to rush that, and there's no need to as well. One common thing that you might have heard is that a painter becomes good at painting just because a painter likes to work at it. I think that when technique and creativity are combined, you do get these really great pieces. And that's what is the most memorable part of visiting a museum. Take, for example, this piece, Raphael's School of Athens. So this is a perspective painting from around the Renaissance. And at the center is the perspective with two very central figures, Plato and Aristotle. Now, Plato is the mathematician. He's on the left, and he's pointing upwards in the piece, probably to allude to some divine knowledge and to show that maybe there's something greater and more perfect that relates to the study of mathematics upwards. According to art historian Beth Harris, there's something in mathematics that might relate to this divine knowledge. And in their writings on the subject of perspective paintings, Renaissance artists were actually very systematic and very mathematical in their approach to making these moving pieces. Leonardo da Vinci even began one of his essays by writing, "Let no one who is not a mathematician read my works." So now that we've kind of thought a little bit about art, the next part of this talk is going to get into what is culturally considered the value of math. I'd like to explain some of the stereotypes that I see in math and also why I personally appreciate it so much. A common way of viewing math is really valuing math only for skills. It's seen as a toolbox instead of an expression. I think that some of the things that we build through mathematics can really be quite fantastic, but unfortunately, I think that the common way of viewing math is being viewed as a means to an end. Even among some of the most talented scientists I know, there's a lot of stereotypes that are built around mathematics, both in our culture, and that results in some misunderstandings about why we would teach math. As a matter of fact, I know quite a few very intelligent people who have unfortunately been very harmed by mathematics. if I mention that I'm a math teacher, sometimes in a relative gathering at a Christmas party, some people think that I might be some kind of cold and logical person. If you get to know me, you know that's not the case at all. But I think that a lot of this is built by stereotypes within Hollywood and within our culture that are just surrounded by mathematics. If you get on TV tropes, you'll find out that there's a lot of negative messages out there that students are really bombarded with. Here are just a few. So just to take you through the slide a little bit, on the scene in Mean Girls, this is Katie, Lindsay Lohan, and she pretends to actually hate math so that she can fit in with all her high school friends, even though she actually really enjoys it at the beginning of the film. She asks the boy that she's crushing on in math class to tutor her, and he's even worse at it than she pretends to be. There's also this stereotype of dry math lectures in high school. So usually the teacher is 100% unaware of the class and assigns a lot of homework. If the setting is in college, then the professor is insane, absent-minded, too intelligent, really doesn't connect with his students. By the way, notice that the professor is often a white male. As another example, Bella in Twilight says that she hates math, and this one's especially harmful at my level, middle school. She says that math is her worst subject, and she hates her trigonometry teacher. Her friend says that Mr. Varner would rather believe that anyone was cheating on him than think that a student was smarter than him. This summer, I also watched Pacific Rim, which was a pretty big blockbuster film. One aspect of the movie, though, that struck me pretty hard was the representation of the hard scientists in it and how they were perceived. The two scientists were both male, both depicted as isolated from other characters, and both were also kind of eccentric in their own way. The physicist was disabled and very followed by his equations and love for math, and the biologist was highly asocial and more curious about the aliens. Both were perceived with their own idiosyncrasies, and they related to each other and not necessarily the rest of the world. Now, obviously, these messages given to students can cause them to feel a number of things about math. And I believe that this is only a reflection of how people perceive math, and a reaction as well. Are there other messages and ways in which students might be harmed by math? How do we know? So here is how I like to see math, though, and why I love it so much. I think that math in its purest form is a way to really invoke universal understanding. Math is looking for patterns, math is looking for structures, and when I go outside in nature, I see math everywhere. And math is a very creative process. Like art, math actually promotes that synthesis and creativity. Think back to that cow, think back to that dopamine release. Why do we want that so much? Well, it's the same reason that I study math personally. And I think that that helps us think of really beautiful solutions to problems and creative approaches to our lives in general. Those of us who have been fortunate enough to have this relationship with math know that there's so much more to it than just worksheets and memorized formulas. Numbers are a very fluid structure, and I believe that part of being human is needing that level of abstraction and taking that abstraction and bringing it into their emotions and being able to relate to the world in that way. Now, this isn't to say math does have its uses too, and I think that when combined with the skills that come with learning math, it can really be emotionally moving. think about how uplifting it was to see the first man on the moon. What brought that about? Newtonian physics, calculus, very hard skills, but that brought such joy and beauty in being part of this world. So, in other words, I think that math is an art form, even though it's often not perceived in that way. And the question is, what drives us to be so inspired and moved to sit down and really do math problems and want to solve it? So you might have heard the story of Archimedes' Principle and how he came about discovering his principle. Legend has it that Archimedes discovered this principle while he was trying to solve the problem of how to tell if a crown was made of genuine gold. He realized that he could determine the material by weighing the crown underwater. And this insight came to him while he was actually sitting in a bathtub. He was so thrilled by his discovery that Archimedes ran through the streets shouting, "Eureka!" in Greek. That means I found it, aha. You know, again, think to the cow, right? He was so excited that he was actually wearing what he had been wearing in the bathtub, according to legend. So I want to focus now on that eureka, or what I like to call an aha moment, and how to capture it in the classroom. Before we get there, though, let's just recap all these ideas. What are the similarities that art and math both hold? And why do I claim that the two are so related? So the key is that remember that we can appreciate art both analytically and also emotionally. We've seen examples of this throughout this talk. Take, for example, the skills that come with art. Consider the School of Athens piece by Raphael. This, of course, stands in art history as a really beautiful piece, but part of appreciating it is Raphael's acquired skill in learning how to paint with perception. We also have an emotional relationship with art, too. Looking at famous paintings gives us that same feeling as falling in love. Now let's think about math. Often we cite the analytical values for it because of all its uses in industry and STEAM careers. And for this reason, I think that a traditional math curriculum will emphasize math skills. But don't forget Archimedes' Principle. Teaching math in its purest form is beautiful. Teaching math is fun, and we keep doing it for that synthesis, right? As a matter of fact, we get so excited sometimes that maybe we will dash out in the streets naked and shouting, "Eureka!" right? So in particular, let's just ask, how do we capture those moments in the classroom and less teaching math for just the analytical part? So let me just say, to start, when I became a teacher first year, I realized some of the mistakes that I made, and some of it was just not realizing that as a teacher, you actually have eureka moments all the time too. It's not always easy to think of it that way, especially when you're busily grading and when you're wondering what's keeping you at it. But staying creative is a big part of being a teacher. And I actually find that I'm constantly looking for those aha moments whenever I start lesson planning. I deeply identified with Lockhart's lament when I first read it. According to Lockhart, the title is "How Our Schools Teach Us Out of Our Most Fascinating and Imaginative Art Form." So mathematics is a performance. It's a way of interpreting the world in the same way that a musician can inspire us with a musical instrument. But few people understand what exactly mathematicians do. I think that in his book, which you can go home and you can Google it, and the PDF will actually come out right away. One aspect of this book, though, is that Lockhart sounds really critical of teachers, but I'd like to say that I'm not. I think that teachers and administrators and parents have had to work in ways that are really educationally damaging. Fortunately, we work at independent schools, or at least I am, where we're given more freedom to do something. But I think that an aha moment is in order first. This XKCD comic kind of talks a little bit about one aspect of being a math teacher. Two teachers are talking in the teacher's lounge. One says, "My students drew me into another political argument." The second says, "It happens. Lately, political debates bother me. They just show how good smart people are at rationalizing. The world is so complicated. The more I learn, the less clear anything gets. There are too many ideas and arguments to pick and choose from. How can I trust myself to know the truth about anything? And if everything I know is so shaky, what on earth am I doing teaching?" In the third panel, the teacher says, "I guess you can just do your best. No one can impart perfect universal truths to their students. Ahem, except math teachers." Thank you. So I think that math in its purest form is that way to invoke universal understanding. A better question, though, is how are we doing it right now? Currently, I'm not really sure that we're succeeding as a nation at this. To impart that universal understanding is very much that human desire, and math is a very abstract way of relating to the world so that we can get there and so that we can rationalize things. Very math students, I think, right now understand that. So I'm just going to give you a little tidbit of something that you could try with some students, and maybe how it might be a little different from our math curriculum. What I'm sharing is a story of two very special friends. They're not your normal kind of friends because they're numbers, but trust me, numbers can be very friendly too. Numbers have a very mathematical friendship, and this is with what is called friendly numbers. So consider the number 220. What are some of the divisors of 220? What's that? 22. Okay, so what I have here is 1, 2, 4, 5, 10, 11, 20, 22, 44, 55. Some of you might have noticed that I disregarded 220, and you're going to find out why in a second. 110 as well? Okay, I should make that fix. So along with 110, 284 is also divisible by these numbers as well. 1, 2, 4, 71, and 142. And of course there's 110, so thank you, I'll make that fix. Add up the numbers that divide 220. Add up the numbers that divide 284. So that's why these are what are called friendly numbers. And as a matter of fact, mathematicians concluded that the numbers 220 and 284 are universal friends. Each of them serve, delight, guard, and honor the other, according to legend. And it's this kind of friendship that I'd want to teach to my students, because it also inspires us to learn about a lot of things. And if you want to go further with this, this is a great place to lead off for factors, divisors, greatest common divisor, GCD, and that's just pre-algebra. You could also start thinking about other places in math where you could take this. There's math proofs that go with this that lead to ideas in exponents, quadratic equations, and you can even go into some programming with it if you wanted. So what is it that motivates us to get the skills? It's recognizing the aha moment first. Now, as a teacher, I just have to say I'm really not an expert at this, and I don't claim to be. As a matter of fact, when I was a first-year teacher, I made quite a few mistakes. My goal was, in every lesson, let's do this, and make that universal emotional response, get kids very excited, get them learning. Every day, they'll learn to problem solve in that way, right? That's how it works in the teaching career. Here's one place where I did it and did not do so, and was not very successful. So I actually taught students the Pythagorean theorem my first couple weeks of teaching, and I asked them to solve a harder version of the problem that we did in class. I thought that maybe they might get inspired by doing this in a testing situation. Now, of course, any teacher who's given a test knows that those aha moments are not likely to happen in a testing situation, nor do they happen while students are nervous, preparing for a test by regurgitation, and they're certainly not critically thinking and problem solving while they're trying to take a test. I actually had a physics teacher who told me that a lot of times students will take a test and then realize in the shower afterwards, oh, I know what I was supposed to do. How many of us have had that? So I'm going to revisit this idea, but first let's talk for a second about one important speaker for education, I think, Carol Dweck. She wrote a book called Mindset, and I highly recommend it. The key finding in her work is that the brain exhibits what's known as neuroplasticity. People used to think that some students had a certain brain for subjects, such as mathematics. So you're a mathematics student, you're mathematically orientated. Meanwhile, other students did not. But it turns out that the brain is actually so flexible that the brain is changing by the minute, and that's what can cause intelligence as a growth mindset. You may have heard of one study that she headed. Excuse me. In this study, Carol Dweck actually gave two sets of students a set of some nonverbal problems to work on. Now, in one group, the students were praised for being so intelligent. Oh, look how smart you are. You were able to do this problem and do it in a very intelligent way. Another group was meanwhile given the same test and were praised for their effort. Look how hard you worked. Look at how hard you're going with this. The first group is what would be known as a fixed mindset. And as this chart shows, that can lead to a deterministic view of the world. So, in other words, later in life, you will encounter challenges, and with a fixed mindset, you won't be very successful when you do. You'll just see it as deterministic. Meanwhile, students who approach things with a growth mindset tend to want to take on challenges and then take it to the next level. So that's what's called a growth mindset, and it's something that has a big impact in math education. To finish that story, both groups were asked to do a harder set of math problems. The students who were given the fixed mindset of being intelligent didn't want to do the harder problems. Later, they actually would lie about their high scores. The group that had that were praised for working hard wanted to do the more challenging problem set because they wanted to continue with their effort. I think that a lot of teachers have a very fixed mindset sometimes in thinking that some kids are math-orientated while others are not. Carol Dweck has actually interviewed recently to talk about how to praise students for math, and Stanford professor Joe actually has a few ideas that stem from that. So in the math classroom, she recommends that students should try things out first, that math is about methods, not skills, and that uncertainty is okay and embraced. And then here's where the growth mindset comes in. Mistakes in math are an opportunity to learn. Furthermore, everyone can get better at math if they work on it. So let's finish the story of what happened to me as a first-year teacher and how you can fix it if you do have to teach to the test. Take the growth mindset approach and give students test corrections. And not only offer it for credit back, but give it back for full credit. That gives students a chance to relate and learn in a reflective way. If you have students who struggle with completing test corrections, just remind them that it's very important to face their mistakes in math because, again, mistakes are an opportunity to learn. So go over those mistakes. Here's what I found when I started offering this last fall to my students. I found that students actually undergo a pretty large series of emotions. At first, they feel a little uncertain, especially when they're learning how to prepare differently for a math test. Eventually, though, they learn to study problems that they need to study because they realize and find the value in that. A lot feel very optimistic when they get their tests back because they want to find areas for improvement. And after they move through their test corrections, their emotions get satisfied and the synthesis happens. And then they understand and write about their mistakes. I'm going to skip the next couple slides because I'm noticing time. Another thing that you can try is consider reading this article by Malcolm Swan. He cites that raising hands in math can actually lead to issues in learning. Studies find that many teachers will actually wait less than a second for students before offering help or giving a student time to respond. So if you're teaching with hands, I recommend not to. Instead, give everybody a chance to respond by putting thumbs to their chest. By using this tactic, students are then given more time to think about their response, and then everyone gets more time to respond, not that 1 second. You just tell them to put it to their chest, thumbs up if they know it. And you'll find that if you pause and wait a little bit, that's very helpful. The other reason that it really helps is because when they use hands, sometimes, especially at my age, middle school, they get a little intimidated by that, right? So by putting it here, they're not looking at their friends. That's a really good question. Honestly, I haven't had issues with it. They'll put it there when they do, and then I call on them, and hasn't been an issue. So it's very interesting. And then, maybe if they do get it wrong, ask them how did they solve it, right? Because that's really where the learning takes place. Again, further reading, I have an article cited at the end of this talk where we can think more about that. It's produced by the University of Nottingham, or Nottington, I'm sorry. So when you allow students to get inspired and then actually have a relationship in math, it's really amazing what happens as they start to think of math as an art form. One piece of advice I was given as a teacher is to find your Yodas. What is meant by that is first let the student think of an idea. As a teacher, keep your mind open, just like you would as an artist. Think of the people who you know, your Yodas, that might help you get that student to that point in their journey. And eventually, you're going to find that with that help and with the support and with the inspiration that the students will find, that that idea is going to happen. And when it does, it's really great. And you see that the skills kind of go on their own. As a couple quick examples of that, the Illinois Geometry Laboratory has actually been very helpful with making ideas happen. We've held fractions versus decimals debates in my class just because students have asked for it. And from that, they conclude that fractions are your friends. So I think that's the kind of classroom that I would like to have that fosters that creativity. And it can get to something really great, too. Last spring, I actually had a policymaker on Capitol Hill come in and talk to us about he spoke to us about minimum wage and how that impacts our Illinois society, and we actually used math and spreadsheets to work with him on an economics level. So a lot of great things can happen, and the key idea there is to think of who you know. I'm just going to close with a very simple Venn diagram. I actually came across this while soul-searching and having a couple of core breakdowns myself. Maybe a little too much time spent living in the emotional and analytical mind in my early and late 20s. But let me just say where we're going with this. On one end, you have your emotional mind. On the other hand is the reasonable mind. But in the center, where we want to be, is a wise mind. And I think that's the kind of world that I would prefer to live in, and the kind of wise mind that we can give to our students as well. Thank you.